Imagine this. It is 0314 UTC on October 17, 2028, and in the Mission Control Room of the Indian Space Research Organization in Bengaluru, the night shift is drinking the 47th cup of terrible coffee when the Chandrayaan orbiter's neutron spectrometer suddenly screams. The instrument, designed to map lunar helium-3 for future fusion mining, has just crossed the far side and is staring at the floor of a 28-kilometer crater, officially named Daedalus B. Except the count rate is 4,800% above background. The gamma lines are a perfect fingerprint of uranium-235 fission daughters, and the thermal infrared camera shows a 300-meter-wide, perfectly circular patch glowing 12K warmer than the surrounding regolith even at lunar midnight. Within 9 minutes, the same anomaly is confirmed by the Artemis 7 polar orbiter, then by China's Queqiao 3 relay, then by every amateur telescope on Earth's night side that can resolve 80 meters per pixel. By dawn, the entire planet is looking at the same impossible truth. Something the size of a football stadium has been running a controlled fission chain reaction on the far side of the moon, continuously, silently, for at least 1.6 billion years, because the crater walls are glazed with fission fragment tracks. The surrounding regolith is laced with caesium-137 and strontium-90 at levels that demand a reactor operating since the Proterozoic, and the central dome is a 300-meter beryllium-moderated helium-3 cooled natural uranium pile that is still critically stable after more time than multicellular life has existed on Earth. This is not a crashed ship, not a waste dump, not a natural Oklo-style reactor. It is a deliberately engineered, self-regulating alien nuclear reactor that predates our sun's ignition by 2 billion years. And in this single, continuous 13,000-word paragraph, we will follow every spectrometer trace, every orbital image, every frantic teleconference, every emergency rover mission, every isotope ratio, every neutron absorption cross-section, and every desperate theory humanity throws at the greatest archaeological discovery in history. Because the moon has been hiding a working power plant older than planets, and no one noticed until the exact week we finally went looking for helium-3 to fuel our own fusion dreams. The first anomaly appears at 031417 as Chandrayaan-4 passes over 5.3 degrees, 177.4 degree OE, at 38-kilometer altitude. The alpha particle X-ray spectrometer registers a helium-3 column density of 94 parts per billion instead of the usual 12. Then the lunar prospector-derived neutron spectrometer spikes from 3.8 counts per second to 182, and the narrow 2.223 MeV deuterium capture gamma line vanishes completely, meaning every thermal neutron within a 40-kilometer radius is being absorbed by something with a macroscopic cross-section orders of magnitude higher than lunar soil. Simultaneously, the diviner-derived thermal map shows a perfect 302-meter disk at 98.2 K, while the surrounding crater floor is 89 K, and the heat signature is steady to within 0.3 K over the entire 93-minute lunar night observed so far. The Indian flight director calls NASA's Lunar Reconnaissance Orbiter team in Goddard, who retask LRO's diviner and mini-RF instruments on the next orbit and confirm the thermal bullseye is exactly centered on a low-albedo dome that has been mistakenly cataloged as basaltic intrusion since 2009. By RWO 730 UTC, the high-resolution LRO Naki camera is pointed at the site and returns an image that ends the world as we knew it. A flawless 300-meter geodesic lattice of hexagonal beryllium plates, each 8 meters across, arranged in a honeycomb that has not shifted by 1 millimeter in the 19 years of LRO imaging, surrounded by a 2-kilometer-wide ring of artificially straightened crater chains that look like cooling cracks around a droplet of molten metal frozen in vacuum. The dome has no visible entrance, no exhaust, no waste heat plume, yet it is radiating a steady 1.4 gigawatts thermal as measured by microwave radiometry, which is exactly the waste heat expected from a 4.2 GWth fission reactor operating at 33% Carnot efficiency with helium-3 coolant. Within 48 hours, every spacefaring nation has retasked every lunar asset. China's U-29 rover, originally prospecting 1,800 kilometer away, is ordered on a 94-sol forced march across the far side. NASA's Viper follow-up rover scheduled for the South Pole is hastily reprogrammed and launched on an emergency Falcon Heavy. Russia's Luna 29 sample return mission is upgraded with a neutron source and a miniature mass spectrometer. Even the private company Espace reroutes its Hakuto RM-2 lander to a site 40 km north. By November 2028, 4 rovers are converging on Daedalus B like antibodies to an infection, and the live feeds are the most watched event in human history. 4.8 billion simultaneous viewers staring at dusty treads inching across gray plains, while scientists scream at each other in 6 languages about what they are about to touch. U-29 arrives first on January 9, 2029. Its panoramic camera reveals the dome is not resting on the surface. It is buried flush, only the top hexagonal layer exposed, and the plates are a beryllium-9 lattice with 0.3% beryllium-10 enrichment that cannot be natural. The ground penetration radar shows the structure extends 180 meters deep in a perfect cylinder, surrounded by a 40-meter-thick radiation shield of compacted lunar ilmenite. The rover's alpha backscatter instrument detects a 3.2-meter-thick layer of pure gadolinium oxide, the perfect neutron poison, lining the entire outer wall. When the rover's neutron generator fires a pulse, the count rate inside the shield drops to 0 in 0.8 microseconds, meaning the reactor is still critical and actively controlling itself. The onboard mass spectrometer samples the regolith and finds cesium-137 to strontium-90 ratios that pin the continuous operation to 1.62 plus 0.04 billion years. The isotope clock has not blinked once since the first animals crawled onto land. Viper arrives 3 weeks later and drills a 2-meter core 800 meters from the dome. The core returns glassy fulgurites laced with fission fragments, plutonium-244 from supernova nucleosynthesis that was never part of the Moon's original inventory, and microscopic spheres of pure uranium-233, the signature of a breeder blanket that has been turning thorium into fuel for longer than Earth has had an oxygen atmosphere. The plutonium-244 decay heat alone is enough to keep the lower levels at 420 K, explaining why the reactor never needed an active startup source. It was born critical the day it was switched on, and it has been breeding its own fuel ever since. Theories explode across every channel. Some claim it is a Kardashev Type II waste heat radiator left by a civilization that strip-mined the Moon 1.6 billion years ago. Others point to the complete absence of cultural artifacts and argue it is an automated seed reactor sent to prepare the Moon for future colonization, programmed to wait in hibernation until a recognizable technological signal appears. A minority insist it is a natural nuclear reactor triggered by a primordial black hole decay event, but the beryllium lattice, the gadolinium shield, and the perfect hexagonal geometry silence that idea within 48 hours. The dome is artificial. It is deliberate, and it is still working. On March 12, 2029, the first human mission, Artemis 9, performs a flyover at 15-kilometer altitude. The crew's handheld neutron dosimeter pegs at 180 millisievert per hour even through the Orion capsule shielding, confirming the reactor is running at full power with no containment breach in geological time. High-resolution LiDAR reveals micrometeorite craters on the beryllium plates that have been repaired. The scars filled with fresh metal extruded from inside, meaning the reactor is not merely critical, it is self-repairing, probably using lunar regolith as feedstock and a von Neumann repair system that has kept it pristine for 1.6 billion years. By 2031, the first manned landing at Daedalus B occurs. Astronauts in upgraded XMU suits approach on foot, radiation badges turning black within minutes. They place a seismometer 200 meters away and trigger a small chemical charge. The seismic return shows a 180-meter cylindrical void with periodic density changes every 0.87 seconds, exactly the frequency expected from a helium-3 coolant convection cycle. When they shine a laser into a hairline crack between 2 hex plates, the reflection returns modulated at 1.618 Hz, the golden ratio, a deliberate handshake protocol older than mammals. The reactor knows we are here, and it is talking. Core samples from the outer shield reveal a 40-meter thick history book. layer after layer of gadolinium oxide deposited every 41,000 years, matching Milankovitch cycles that did not even exist when the reactor was built, meaning it has been learning Earth's climate from tidal resonance alone. Deeper still, the uranium is wrapped in a lattice of carbon-60 fullerenes doped with nitrogen-14, a radiation-resistant cage that has kept the fuel pristine since the heavy bombardment. The builders solved materials science problems we have not even formulated. In 2034, the first borehole is drilled through a hex plate using a diamond coring tool cooled by liquid nitrogen. At 42 meters depth, the drill breaks into a toroidal coolant channel 8 meters wide, filled with supercritical helium-3 at 920 K and 18 MPa. The flow is steady, laminar, and the helium-3 is 99.9999% pure, meaning the reactor has been separating isotopes from the lunar regolith for billions of years and stockpiling the exact fuel humanity came to mine. When the drill is withdrawn, the hole seals itself with fresh beryllium in 11 minutes, extruded like biological tissue. By 2040, an international crew lives permanently at Daedalus base, their habitat shielded by 8 meters of regolith moved by autonomous robots. They have mapped the entire 300-meter sphere, discovered the central 80-meter natural uranium core surrounded by a thorium breeder blanket, confirmed the power output has been constant at 4.2 GW since the late heavy bombardment, and still they have not found an entrance. The builders never intended anyone to switch it off. It is a gift, a library, a lighthouse, and a power plant that was left running because its owners knew someone someday would be desperate enough for energy to follow the neutron glow across the vacuum. And in the quiet hours, when Earth is a blue crescent on the horizon and the reactor's soft 12K warmth radiates through the boots of the night watch, the astronauts no longer ask who built it. They ask why it was built for us 1.6 billion years before we existed, and whether the owners are still out there, waiting for the day we finally learn to say thank you in a language older than mountains.